In this video, we're going to talk about repeated linear factors in the denominator. As you can see the title as it comes crashing down. In the previous two videos, we discussed non-repeated linear factors in the denominator. We went through a couple of examples, and now we're going to discuss, the steps needed to perform partial fraction decomposition with repeated linear factors. So as you can see on this slide here, I have an exponent of 2, and anytime I have an exponent of 2 or anything greater than 1, that's telling me that I have a repeated factor. And inside the parentheses here, I have an exponent of 1 on my variable x. So that's telling me that the factor is linear and that you can see the little animation popping up there, that the factor itself is going to be repeated. And you have to deal with repeated factors a little bit differently than the non-repeated factors. So if I expand out the x plus 1 squared, that would be x plus 1 times x plus 1. Okay, so when we create our partial fractions, when we do the decomposition of this expression here, so you can see we're going to have to account for all powers up to and including the factor itself. So we have a factor or a power of 2. We're going to have to wind up including all the powers up into that power of 2. So both of these here are powers of 1. So if you multiplied these out here, you would obviously get x plus 1 squared. Well, we have to account for the power of 1, and we're going to have to wind up accounting for the power of 2 when we create our partial fractions, as you can see as it pops up on the screen. So we have to account for x plus 1 to the first power and x plus 1 to the second power in our denominators of our partial fractions. And you'll see that as I do the initial decomposition here. So we were going to create our initial fractions. And again, this is a linear factor here because I have an exponent of 1. So when we create our first fraction, my numerator is going to be a constant because your numerator starts 1 degree less than your denominator and it goes down to the constant. And you can see we have a linear factor. So this one would be x plus 1 to the first power. So we have to account for x plus 1 to the first power. And we're always putting plus signs in between our fractions when we do the decomposition. And we also have to account for x plus 1 to the second power. So we need every power up into that power of 2, as you can see it. So that would be your partial fraction decomposition for this fraction right here. And actually this number, this power here, actually tells you how many fractions you need to create for just that one factor. So this is a power of 2. This is saying that I need 2 fractions just for that one factor. And if we had something that looks like this, if we were going to decompose something like this, 2 over x plus 1 cubed, then again, this would be a linear factor. So we would need, in the numerator, we would need an a, but we would have to account for x plus 1 to the first power, and then we would go to the next fraction. It will be b over x plus 1 to the second power, and we would need a third fraction for x plus 1 for the third power. Okay, so that's how that is going to work out. If like I said, if this was a power of 3, we're going to need a fraction for all 3 of those powers: first, second, and third power. And that's how you have to handle the repeated factors in your denominator. So now we're just going to walk through all the steps in decomposing an example. All right, so here's the example we're going to do. And in the first step, again, if you've seen the previous 2 videos, the first step of my 7-step process, and usually the first step in general here is going to be factor your denominator. And we lucked out a bit because my denominator is already factored. There's really not much to do there. But at this step is really where you want to identify your factors. So since both of these exponents are 1, both of these factors are going to be linear. We know that. And this factor of 1 here is telling me that this factor here is non-repeated. So we know when we create our partial fraction, I only need 1 fraction for this factor. But when I see this factor of 2 over here, this repeated factor, that's telling me that I'm going to need 2 fractions just for that one factor. All right? So this is going to be the repeated factor. So now we're going to begin the decomposition step. And step 2 is the decompose, as I just said. So we have the function without the function notation, and again, it's already been factored. So now we're going to start creating the fractions, and I'm going to need a fraction for x plus 2, and it's a linear non-repeated, so we're going to start with x plus 2. And since it's linear, we're going to fill in our numerator with a constant, and we're going to start with a. And then we're going to put a plus sign in between my next series of fractions. And we're going to need a fraction to account for x minus 1 to the first power. And again, that's also a linear. This is a linear factor. So my numerator will continue with b. And we're going to have one more because we need to account for that power of 2. So we're going to have another plus sign. And you can see now we have the final... We've reached the final power there, power of 2, and it's still linear, so we're going to continue down the alphabet with a numerator of c. So again, this power is telling me I need 2 fractions just for that one factor, and then I needed a fraction for this one factor, so then again you have the 3 fractions. So now we're going to continue along in the process. We'll go to step 3. All right, so now we're going to get rid of the fractions. So we're going to multiply both sides of the equation by the denominator of the left side. You can see on the step title there. So I'm going to bring in the equation. There it is. And what we're going to do is I'm just going to multiply the entire equation by this denominator here. So we're going to bring in the brackets, and we're going to bring in the denominator. So there's your denominator, x plus 2 times x minus 1 all squared. So what I'm going to do is we're going to multiply this times that, and what's going to happen is the x plus 2's will cancel, the x minus 1 squareds will cancel, so I'll be left with 3x squared plus 4x plus 5 equals, and then we're going to have to multiply this expression times all 3 of these fractions. And when I multiply this fraction times this, you can see the x plus 2's will cancel, so we'll have a times x minus 1 quantity squared left over, so I'm going to write that. So we'll have x minus 1 all squared. And then we want the plus sign. So now we're going to multiply the second fraction times this expression. And one of the x minus 1's will cancel here. So I'm still going to have one x minus 1 left because we have a square there. So when I multiply that, we're going to have b times x plus 2 times x minus 1. And then we just have to do it one more time. We're going to multiply it times this fraction. And this time the x minus 1's squareds will cancel. So we'll have just c times x plus 2. So I'm just going to write that. So we'll have c times x plus 2. And we'll wind up working through the rest of the problem like this. So you'll see this drop in now, all nice and cleaned up. And this is exactly what I have over here. So you have 3x squared plus 4x plus 5 equals a times x minus 1 all squared, plus b times x minus 1 times x plus 2, and then plus c times x plus 2. So now what we're going to do is we're going to wind up removing the parentheses and then continuing along in the process. All right, so the next step says expand the right side and group. So here is the exact equation as we left it from the last slide. So what I'm going to do is I'm just going to expand my parentheses. All right, I just want to expand the parentheses first, and then we'll deal with the a, the b, or at least the a and the b. The c we can distribute into the parentheses now. So when I do that, when I expand this x minus 1 squared, you get this. You get x squared minus 2x plus 1. And you can see right here, when you expand this binomial, you're going to wind up getting this. So this is just this squared, and that's what I have right here. And then we're going to multiply these out. When you multiply x minus 1 times x plus 2, you're going to wind up getting this. So there's the x minus 1 times x plus 2, and you get this multiplication, so I put it right there. And then as I said before, all I did was multiply c times x and c times 2, and we have this. So now what I'm going to do is I'm just going to distribute the rest of the way into my parentheses. We're just going to take care of the rest of the parentheses. And this is what we're going to have. You're going to wind up having 3x squared plus 4x plus 5 equals ax squared minus 2ax plus a. Again, after we multiply all this, this is what you get. And then we're going to take care of the second grouping of parentheses here. We're going to have bx squared plus bx minus 2b. And then we just brought down the cx and then the 2c. And then the next thing we need to do is we need to group like terms in the parentheses, okay? So I'm going to group anything with, I see a couple of squares here. I'm just going to put some boxes around them. I want to group these two. And I also have some x to the first. I think I'm going to group those like this. We'll have minus 2ax, we have a bx, and then we have a cx. And I also want to group your constant terms, okay? And then the constant terms won't have an x, so it's just going to be, we'll have an a negative 2b, and we'll have 2c. So those are going to wind up getting grouped in the parentheses coming up now. So you can see that right here. We have, as you can see it, we have the ax squared and the bx squared all grouped right here. And then we have all the common x to the first here, the negative 2ax plus bx plus cx, all grouped in these parentheses. And then my constant terms, a minus 2b plus 2c, are grouped in that last one. And all I'm going to do now is I'm just going to bring down the rest of the equation, what we had on the left side, 3x squared plus 4x plus 5. And you can see that. That'll pop right in there. And that's what we're going to use in step 5. We're going to wind up doing some factoring, and then we're going to do some matching. So here's the rest of the steps. Number 5 is this says factor and match to left side of equation. So here's where we left the last slide. Here's the equation from the last slide. And again, if you've seen, the other two videos I did, you only have to factor your parentheses with x's. So I don't have to worry about this. If I don't see an x in my parentheses, I don't have to worry about it. I'm only going to wind up factoring this one and this one. And then what we're doing is, all we're doing is taking the x terms and we're just kind of bringing them outside. All right, I'm going to do the same thing with these x's here. We're just going to bring them on the back side of the parentheses. So you can see that, that'll pop in. And that's exactly what I did. So out of that first parenthesis, all I did was factor out an x squared. You can see it right here. And we're going to be left with a plus b. And then the second parenthesis, all I did was factor the x out of this group. And you can see it right here. And then we're left with negative 2a plus b plus c. And then in the last group here, I didn't factor anything because that's a constant group. Anything without an x is a constant group. So now what we need to do is the match. This is the second part of step 5. We need to match it to the left side. And again, this is something I had covered in the last couple of videos. What we have here is an equation. So that means that the left side has to equal the right side. So every coefficient that I have on the left side has to match up with a coefficient on the right side. So this 3 will have to match up with a plus b. It's equivalent to it, so I'm going to write that. I'm going to say that a plus b is equal to 3. All right, and then the same thing is going to be true for this 4. This 4 has to be equivalent to this coefficient in front of this x. So I'm going to write that negative 2a plus b plus c is equal to 4. And then we have to do this one more time. This 5 has got to be equivalent to these placeholders that represent the constant term. So I'm going to write that a minus 2b plus 2c has got to equal 5, okay? And what we have here is basically a system of equations that we're going to wind up solving in the next step to figure out how we fill in our numerator. So here is here's the little animation that I did. You can see it all match out. This 3 again is going to match up to a plus b. This 4 will match up to negative 2a plus b plus c. And then the 5 is linked up with a minus 2b plus 2c. So again, here's the system. It's going to drop down. And you have a plus b equals 3 is what I have. Negative 2a plus b plus c equals 4. And then a minus 2b plus 2c equals 5. And what we're going to do is we're just going to solve this. So we're going to go through the series of steps to solve the system, find what a, b, and c equal, and then we'll put all the fractions back together. So we're going to go to step 6. All right, step 6, solve for each variable. So I'm going to bring in the system from the previous slide. There it is, a plus b equals 3, and then the rest of it. And we're going to solve this. So the easiest thing to do, now you see these two equations have a C. This one does it. So when you have this kind of mixed match system, the easiest thing to do, now you could use substitution here and solve it using substitution. I'm just going to use elimination. So when you have this mixed match situation, I'm going to combine these two and get rid of the C, because then everything will have an A and a B. So the first thing I'm going to do is we're going to remove C, the uncommon variable. And you can see it right here. We have the negative 2A plus B plus C equals 4, and A minus 2B plus 2C equals 5. That's these two. We're going to remove those. So what I'm going to do is I'm just going to multiply the top. We're just going to multiply the top by negative 2. So we're just going to distribute a negative 2 into those parentheses, and you can see what's going to happen over here. So when I do that, again, you're going to have negative 2 times negative 2a is 4a, and then negative 2 times b is negative 2b. Negative 2 times c is negative 2c, and then we have negative 8. Now that we have this situation, you can see that we can cancel the c's. Those can go. So we're going to combine these equations, and now we can add everything. So when we do that, you can see we're going to have 4a plus a is 5a, we're going to have negative 4b, and then we'll have negative 3. Now that I have this equation with 5a minus 4b equals negative 3, I can pair it up with this one, and we can wind up getting rid of a or b. So that's going to be the next step. That's going to be step 2, and you can see it. It says solve for a or b. So you see me I brought this down. This is 5a minus 4b equals negative 3. That's right here. And then I brought down this one. So I think what I'm going to do, I'm still going to use elimination. So I think I'm going to remove or eliminate the b's in this one. So I'm going to multiply the bottom equation by a 4. Again, substitution would work just fine here. So we're going to multiply all that by 4. And you can see we have that. So now that the b's can cancel, because I have negative 4b and a positive 4b, the b's can cancel. After we distributed the 4, I'm going to put my plus sign in my addition bar, and then we're going to combine the terms, and you can see the b's are going to go, and I have 5a plus 4a is 9a, and then we're going to get 9, and we're going to solve for a. We're going to get a equals 1. So now that we have the first variable found, what I can do is I can substitute that back in this equation, because then we can find b. That'll be my next step. That's going to be my step 3. You can see it says solve for b. So all I did was I took the 1 for a and I substituted it back in that first equation. You can see it right here. And we're going to solve for b, and we can see that b is going to equal 2. And you can really see at this point that now it's really come together. We have 2 of the variables found. We just need to find that last variable. So I have a and b. We can substitute those back into either of these two. It doesn't really matter. I think I'm going to use this one. This one looks a little bit easier. So we're going to substitute that back in. So you can see it was solving for c. So I substituted the 1 in for A right here, and then I substituted the 2 in for B right here, and then we'll solve for C. So we have 0 plus C equals 4, and then we're going to wind up getting, because if you multiply that out, we're going to get negative 2 plus 2 is 0, and we're going to get C equals 4. So now we've found all 3 of our variables. So now we can pretty much go to the next step, and just basically, which is just putting the fractions back together. Here's the rewrite as partial fractions. And if you remember on the last slide, we said that A equals 1, B equals 2 when we found C equals 4. So then we'll just substitute these values back in for A, B, and C. And you can see in its glory there, all finished, all put back together. We did our partial fraction decomposition. So again, that's the whole process. And this time we did it with a repeated linear factor. Hopefully you enjoyed the video. Again, when you're doing repeated factors, you have to account for all the powers leading up to that factor of 2. So we need to account for the power of 1 here. And we'll just continue along in the series here. So the next video will probably tackle a non-repeated quadratic factor, and then just move along down the line. So again, hopefully you enjoyed the video, and looking forward to catching you in the next one. Take care.